Hello student. So today's topic is understanding quadrilaterals. So in this chapter we are going to understand what are quadrilaterals and what are the very basic properties of quadrilaterals. Alright. So to start with, I would first like to tell that I'm sure like every one of y'all know when we have 2 points and when we join these 2 points, a line segment is formed, right? Similarly, when I take three non-collinear points. So what do you mean by non-collinear points? So non-collinear points are the points which are not on a straight line. So let us take a point here, here and here, right? So these are non-collinear points wherein not all the points lie on a same straight line. So let us see when we join them in the pairs, what figure is formed. So let me join these two as a pair. Let me join these two as a pair and let me join these two as a pair. So what is formed? A triangle is formed. Now similarly, let us take 4 points, 3 of which are collinear, right? So let me take these 3 points collinear which lie on a same line and one above it, right? So when I join them in pairs again, here a pair and here. So again we see a triangle. Now what happens when 3 of the points are not collinear? Alright, so let me take 2 points here and 2 points here, right? So now let us join them again in the pairs. So let me join these two as a pair, these two as a pair, and these two as a pair. So what figure do we see? So this kind of figure is known as a quadrilateral. Alright, so basically quadrilaterals are four-sided figure. So here to enlighten more on this quadrilateral, if I break it into two parts, quadri means 4 and lateral means sides. So which means quadrilateral is a four-sided figure, right? Is this clear to everyone? Alright, so now if this is a quadrilateral, any four-sided figure is a quadrilateral. So we have a lot of quadrilaterals, say it a square, a rectangle, a parallelogram, a trapezium, and many more. So today we are going to just explore some of the very basic properties which satisfies with all the quadrilaterals, right? Now, when I see this quadrilateral, right, and when I break this quadrilateral into two parts, so let me just join AC. So what do we see here? We see two triangles. ABC is first triangle and ABC is second triangle, right? So what do we understand from this? That a quadrilateral has two triangles. Two triangles together form a quadrilateral. Either way, correct? So now, as we already know that sum of all the angles in a quadrilateral add up to 180 degrees. So which means angle sum property of quadrilateral is 180. And here we can see in our quadrilateral, we have two triangles, right? So each triangle measure is 180, right? So two triangles measure will be 2 into 180, which is equal to 360 degrees, correct? So basically, angle sum property of any four-sided figure is 360. Now, we will see it more in a detail, like why is it 360, correct? Now, before moving ahead, I would like to explain you a very easy example, a very nice visualization of a triangle whose angle sum property is 180, right? So for that, let us consider a triangle. Let us take this triangle A, B, C. All right. And what I'll do is, I'll just take 2 points, one on AB and one on AC and join them. right? Now I'll just draw perpendiculars on the base. Correct? So what we are doing now, I'm going to show you a visualization procedure for the angle sum property of a triangle. All right. So let me just measure, give them some angles, angle 1, angle 2 and angle 3. Right. Now what happens when I fold this part, ADE triangle, to the bottom? So naturally, A is going to fall on the base. So which means this is 2, right? Similarly, what happens when I fold this part of triangle? So when I fold it towards the inside, this angle will fall here. Correct? Similarly, what happens when I fold this part towards the left? So this angle falls here, right? Now we can see that 1, 2 and 3 are on a same straight line. So angle on a straight line is always equal to 180, right? So we are very clear with this concept, but this is a visualization procedure which when we teach students in this manner, when we ask them to visualize and see, so students really find it more interesting and their minds start working and they themselves get in more ideas, which is a very useful and important thing. All right, now using the same concept of angle sum property of a triangle, we are going to see the angle sum property of a quadrilateral. All right, so let me just draw a quadrilateral. Any four-sided figure is a quadrilateral, we have already seen. So let me just name A, B, C, D. Now this is a quadrilateral. So what are the four sides here? Side AB, side BC, side CD and side DA. So a quadrilateral has four sides. Also it has four angles. Angle A, angle B, angle C and angle D. Similarly, it has four vertices. Angle A, B, C and D. These are the four vertices. Alright. Now what are we going to do? I am going to divide this quadrilateral into two parts. Right. So we can see that the quadrilateral is divided into two triangles. ADC, triangle ADC and triangle ABC. Correct? Alright. So now what we'll do, I'm going to give them a measure, a basic angles, right? Like this one, I'm going to consider 1, 2, 3, and this part 4, 5, 6. All right, it becomes very easy when we take numbers. We need not, we need not write the whole angle again and again. All right. Now, here we are going to see the angle sum property of a quadrilateral. We are going to prove. So now when I consider triangle ADC. So as we have already seen from the visualization point of view that sum of all the angles in a triangle is 180, right? Similarly, the same concept will be applied here, that angle 1 plus angle 2 plus angle 3 is always equal to 180 degrees. Correct? So in this, let us take this as equation 1. And in the bracket, I am going to write the reason, angle sum property. So when we are doing geometry, we need to make sure that we write reasons after every step. Similarly, when I consider triangle ABC, again we can use the concept that sum of all the angles of a triangle is 180. So angle 4 plus angle 5 plus angle 6 is equal to 180. And let me give this equation a name 2. So again the same reason, angle sum property. Correct? Now what are we going to do? I would like to add both the equations. So what I'll write? Add 1 and 2. Right? So what I'll do is I'm going to add the LHS on the left hand side and I'm going to add the RHS on the right hand side. So angle 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals 180 plus 180. Now, as I can see, 1 and 6 are together and 3 and 4 are together as in adjacent to each other. So in my next step also, I'm going to write them together. Like 1 and 6, I'm going to write them together, and we can see 3 and 4 are together. Correct? You'll understand why. And what are the left out ones? Angle 2 and angle 5. And 180 plus 180 is 360 degrees. Correct? So now 1 plus 6. So angle 1 plus 6 is nothing but complete angle A. Correct? So I will just write angle A. Similarly, 3 plus 4 can be written as angle C. When I add 3 and 4, I get the whole angle C. Correct? Angle C. Angle 2 can be written as D, and angle 5 we have given the name as B. Right? Equals 360 degrees. So let me just write it in the order. 1A plus B plus angle C plus angle D is equal to 360 degrees. From this, we can clearly say that sum of all the angles of a quadrilateral is 360 degrees. Right? Now, moving forward, I would like to explain you a very basic, a very important and interesting pattern that we have seen till now. So let me take a triangle, right? Triangle, how many sides do we have? 3 sides. We have 3 sides and 1 triangle, right? And we also know that the angle sum property is always equal to 180 degrees, correct? All right. Now let us take a quadrilateral. See, I'll just show you a very interesting pattern from the analysis that we have done. So a quadrilateral has 4 sides. And how many triangles do we have in a quadrilateral? We have seen 2 triangles, correct? Yes. So the angle sum property is nothing but number of triangles into 180 degrees. And that is how we get 360 degrees. Yes. And one more very important point. You will see that the difference between the sides and the triangles is always equal to 2. I'll give you more examples so that you'll feel more confident. Now, after the 4 sides, let me take 5-sided figure, pentagon. So I would like to draw this for you. 5-sided figure is known as pentagon. So we clearly know it is 5 sides. And how many triangles does it have? So what I'll do, I'll just divide this here and just again draw a line. So we see 1, 2, 3. Altogether 3 triangles. So I'm just going to write 3 triangles. Now again a very interesting pattern. The difference between the sides and the triangles is always equal to 2. And how do we find the angle sum property? It is the number of triangles into 180 degrees. Correct? So which will give us 540 degrees. Yes. Now one last example I would like to show you for a 6-sided figure known as a hexagon. So this is the figure which has 6 sides. And how many triangles? Let us just see. Let me join this one. Let me join these pairs and these pairs. So we have 1, 2, 3, 4. 4 triangles. So here also you can see the difference is 2. And what is the angle sum property? 4 into 180, which gives us 720 degrees. Yes. Now we are going to see what is the pattern actually. All right. So if I consider the sides, the triangles and the angle sum property. Right. So 3 sides, 3-sided figure is known as a triangle, which is one triangle, and the measure is 180. Now, if I increase the 4 sides, the number of triangles for a quadrilateral we have seen 2, and the measure is 360. Right? If I consider 5 sides, the number of triangles we have seen is 3, and the measure is 540. Similarly, if I take 6 triangle, the number of triangles it consists 4 and 720, and so on, right? So from this very interesting pattern, if I have n sides, all right, if a polygon has n sides, how many triangles will it have? It will have n minus 2 triangles. As we clearly know that the difference between sides and the triangles is always 2. So therefore, sum of angles will be equal to number of triangles into 180 degrees. So this is nothing but it is applicable for any kind of polygon, be it a 6-sided polygon or a 7-sided or a 10-sided. So for example, if we have a 10-sided polygon, which is known as a decagon, all right? So when we have a 10-sided polygon and when we are asked to calculate the angle sum property of a 10-sided polygon, so it should be, the formula is n minus 2 into 180, which is equal to 10 minus 2 into 180, 8 into 180, which will give you 1440 degrees. So this is how you can easily find out that sum of all the angles in any polygon, any number of sides is always equal to n minus 2 into 180, right? So this is a very interesting and nice pattern. I hope you like the video. Thank you.